exercise 5.5 students. I am taking question 11. It is x cos x raised to power x and plus x sin x raised to power 1 by x. Now, see, whenever we have this thing, this doesn't correspond to any of the standard forms which we have read till now. So, but natural it is that if y is equal to this thing, then we will take this to be I1, this to be I2, and we will find the derivatives of I1 and I2 separately. That's the only way out. So what we will do, we will take here, let I1 is equal to what? X cos x raised to power x. Then taking log both the sides, so what I will get is log I1 is equal to, taking log of this thing, so what I will get is log of this, log x cos x raised to power x. So log m raised to power m will fetch you what? X log x cos x. This much of thing. Now here see, if I take the differentiation both sides, so what I will get here? It will fetch me differentiation of this whole thing. See, differentiation is also expressed by dashes. In your book, see, whether I write dy by dx or I write y dash, and at times, see, when we are using the second derivative, etc., then this y1 symbol at times will also be used for denoting the first derivative. So here, see, now I will take log of both this whole thing. So this is again dash of this thing. Now log I1 dash. So what basically it is? So now see, I will okay. Let me do this question that way. Then so it is basically d by dx of x, and then this whole lot is to be taken as first function. Now before I will take this thing later on, but here I would like to tell you that see, this is log x cos x, log of x into cos x, this whole thing. Okay. Now please see, you have to take the differentiation of this thing. This you can assume it to be first function, and this whole lot to be the second function. You will apply the chain, this thing, product rule. First function, derivative second function into derivative of first. But here I would like to tell you now that since you have now acquired lot much of perfection, so writing a derivative of log x cos x, see, I will do this thing in the manner in which it is to be done. But then again, see, now see, I will be writing directly also at times. That skill you need to understand, because all the time doing this thing by putting this the innermost function t and then differentiating this external function with respect to internal function, and then taking its product with the derivative of internal function being differentiated with the independent variable x. This thing now we will cut short a bit, but in examination, see, depending upon what type of question is being asked, you have to be very particular that what steps have to be written. No, I here purposely take here this question here. Suppose I had to find the derivative of d. Let me do here d by dx of log x cos x. Now see, it is plain clear that this is the product of two things, this is log. So if this is the internal function x cos x, then log x is the external function. So without doing all the formalities, I can directly also write it. What this log x is the external function. X cos x I will assume t. So log t I have to differentiate with respect to t. So what that will give me? 1 upon t. See, 1 upon t, log t, the derivative, t is internal function, x cos x. So it will become log t. So now this external function is to be differentiated with respect to t. So d by dt of log t will be what? 1 upon t. So it will be 1 upon cos x and then dt by dx. And dt by dx is, t is your x cos x, it is the product rule. So first function into derivative of second, that is minus sin x plus cos x into x1. So this is the derivative which you can write directly also. Now see, you had to gain perfection in writing the derivatives straight away. Because now suppose you take another function, suppose you had to find, it is off the this question, suppose log, then under root, then it is say sine square, and then again say it is e raised to power under root x. Suppose this is your function, fairly long function, and a combination of lot many functions. So what is to be done is that, see, step by step we had to do it. First of all, this whole thing, sine square e raised e root x, we will assume to be the internal function, and we will differentiate rather this under root this whole lot. We will take to be the internal function. That is, see what we will do. We will put t is equal to what? Under root sine square e raised to power root x. I will tell you that how directly we can write and how step by step we can write. Now see, you have acquired fairly good perfection in doing this derivatives of function of functions. So that's way, without consuming much time. But in examination again I forewarn you that you have to do it. I will do it by both the methods. So log of this thing. So this whole lot is to be taken t. So this becomes what? D by dt of log of t into dt by dx. Please see. One by one I will do it. Log t will you give me 1 by t. Now dt by dx. Please see. T is equal to this much of thing. Now what I will do? I will put this again is a function of function. So sine square. Now what I will do? P I will put how much? Sine square e raised to power root x. And then see, this t will become how much? It will become under root of p. Under root of p. So what I will do? Now dt by dx will give me what? It will be d by dp of root p into dp by dx. Please see. D by d is 1 by 2 root p. And dp by dx again I will try to find from here. So my problem reduces to p is equal to now sine square e root x. E root x. Now here see, I have to further identify what this function happens to be. So here see, this is sine square. Please see, this sine square can well be written to be what? Sine e root x raised to power x. Now it is easy to identify what is my internal force function. It is P is equal to say Q square, where Q is sine e root x. Sine e root x, let me take it to Q. Q is equal to how much? Sine e raised to power root x. See, lot many things. So it is P is equal to Q square. Now dP by dx will be equal to what? D by dx of Q square. And this thing can be further written to be what? D by dq of Q square into dq by dx. dq by dx I will calculate from here. And this is what? 2q dq by dx. So 2q, let me put the value of 2q here. Q is my sine 2 and sine e root x. And then dq by dqx I will multiply here. I will try to determine from here. So please see how till what stage I have reached. dt by dx is 1 by 2 root p. dt by dx 1 upon 2 root p I am writing here. Please see. Root p is what? T. Root p is what? This root p is t and t is this much. So it is this t is equal to root of p. P is this much. Please see. dp is this much, sine square e root x. So I will put here sine square e raised to power root of x. Please see. And then see, this thing will give me what? This is giving me dp by dx also. Now into dp by dx, please see. And dp by dx I have calculated from here. It is what? This much of thing into dq by dx. So into dq by dx, please see. And so what I will do, I will write this thing to be what? 1 upon t. T is my what? Root of p. P is how much? P is this whole lot, under root of this whole thing. Initially I have assumed like this. Where is my p? Where I wrote p? P is this much of thing. See, sine p root x square. So t, and where is my t? T is root p. Okay, prior to it log t 1 upon. So t must, what I would have assumed, t is like this whole thing. So it is 1 upon under root, please see, sine square e raised to power root of x. And then 1 upon 2 under root, how much? This is log and then under root 1 upon 2, then sine square e raised to power root x, and then dp by dx. dp by dx you have calculated here. It is into 2 sine e root x into dq by dx. And dq by dx we will determine from here. Rest of the things I am now rubbing it off so that you don't get trouble. So here I will write what? dq by dx. dq by dx. And then see, I will write the answer separately. Okay, I am rubbing all the things here. Here. I will only take from dq by dx now. Okay, and I will show you that how later on you can find the result directly. Now, dq by dx, please see. It is, your q is sine e raised to power root x. Please see. You have got this much of thing. Now please see, now here it is sine. This whole lot, you will put some s. Suppose it is s is equal to e raised to power root x. So dq by dx will be equal to what? D by dx of sine s. And then this thing you can write to be what? D upon ds sine of s into ds by dx. Sine s is cos s. S is e root x. Okay, and ds by dx we will determine from here. ds by dx we will determine from here. D by dx. It is again function of function. Please see. So what we will assume here now? So dq by dx is this thing into ds by dx. So please see, I will here at place of dq by dx, what I will write? Cos of e root x and ds by dx. This is. Now, ds by dx we will determine from here. Here again it is a function of function. So what I will do? I will put say k is equal to root x. K is equal to root x. So this becomes d by dx of e raised to power k. So this is d by dk of e raised to power k into dk by dx. And dk by dx from here, it is what? X raised to power 1 by 2, so it is 1 by 2 root x. Okay, so now this is, and d by dk e raised to power k is e raised to power k, and dk by dx is what? 1 upon 2 root x. Okay, and ek, what is k here? K I have kept to be e root x. E root x 1 upon 2 root x. Now this value we will put at place of ds by dx over here. So this ds by dx is what? 1 up e raised to power root of x into 1 upon 2 root x. So this whole lot will be the derivative of this function log, what was our function? Function was, I think, where we have written, I think we have rubbed it, but it was log of, I will write here from here, I can construct it. It was log under root sine square e raised to power root of x. This was our function, and this is the derivative of this whole log. is this much of thing. So this is how we actually will do it. But then see, now we will not waste our time. We will try to write it directly. So how? First see what I will do. I will assume this whole log of this external most function will, this whole lot I will take to be t, that is under root sine square e root x. So log t, its derivative is 1 upon t. So 1 upon sine square e raised to power x. Then I will come to this much. I will forget about now. Now this was my internal function. Here again it is, so it is here this under sine square e root x under root. So under root is the outermost function now. So this sine square e root x I will take to be p and under root p, and derivative of under root p is what? 1 upon 2 root p. So this term will come, and then you will be left with this much of thing, sine square e root x. Now sine square e root x is what? Again see, what is the outermost function? It is x square and then sine e root x. Please see, this may create a little bit of confusion, because sine square e root x, it is to be construed like this, sine e root x whole square. So here the internal function is this thing. So this will correspond to your this standard form x square. So it will be 2, and suppose this is something like q. So q square is what? 2q. So 2 into q. See, this term will come. 2 into q. Q is sine e root x. Sine e root x. And then see, here you will take then this to be your internal function. This is to be differentiated with respect to x. So sine is the outermost here. E root x is the internal most. So sine e root x, you will put some other function, say s. So sine s is what? Cos s. So cos s, this term will come here. And then e root x. Again e root x. Here it is e raised to power root x, you have to keep to be some other variable. So then it will, suppose if you are putting it equal to say m, so e raised to power m, d by dm is e raised to power m, and then root x is 1 upon 2 root x. So this is how you had to do it eventually. See, so at times you have to be wise enough now. Now we will directly write the result here, assuming that we know that the function which has to be differentiated, that has what is the outermost function, then what are the intermediate function in one after other, and then what is the innermost function. And then see, one by one we will be differentiating it, and we will be writing it directly also. So now this practice we will adopt now. So now let us come back over this original question here, to question number 11, because this now perfection you have to acquire, because you have to write it quickly. So this in the application, now see how you will be writing it. Log I dash. So d by dx of log of I1, this is what you have to differentiate. Now, but natural, I1 is what? I1 is this, and this is a function of x. So it is a function of function. I1 being innermost. So naturally what you will do? You will write it d upon di1, log of I1, and then di1 upon dx. This is your left hand side. Okay, so this will be eventually 1 upon I1 into di1 upon dx. Let us see here. Now here this function, of course, I1 is your this thing, so we had to find the derivative of what? D by dx of, yes, this thing, d by dx of x cos x, no, this thing, x of d by dx of x into log x cos x. Now this is your second function, this is your first function, and you have to find the derivative of this thing. So this is what we see, first function x into derivative of second. Now derivative I will write directly, making use of it. This derivative is what? Log of x cos x, I will put t. So log t, differentiation is 1 upon t. So it will be 1 upon x cos x, and then derivative of x cos x. It is again the product of two functions. So first function into derivative of second, that is minus sin x plus cos x into 1. This is how we have to do it. So this is the derivative here. First, first function into derivative of second. Second is log, please see what log cos x. So it is 1 upon x cos x. First you will differentiate this thing and then the derivative of this. This is the internal function which is the product of two. Then you have invoked the product rule. So this thing plus what? Log x cos x. This is your second function and into derivative of x, that is 1. That is 1. This is how you will be writing it. And now we will simplify it. This x you will multiply inside. Okay, you multiply it, so x will cancel. And what you will be left with is, please see 1 upon cos x. Okay, this thing into x. Okay, one more x here. So cos x minus sin x. This thing can well be written to be what? Cos x minus sin x. Okay, within bracket plus how much? Log of cos x. Log x cos x. Please see log x cos x. Okay. So and this is what? 1 upon d. This is I1 dash here. D upon di1. Log I1 is 1 upon I1. 1 upon I1. 1 upon I1 and this 1 upon I1 like this thing. So I1 dash will be your I1 into this whole lot. This is giving you what? X and within bracket cos x minus sin x upon cos x. Okay, and yes, this whole lot plus log of x into cos x. This is your I1 dash. Please see and put the value of I1. What is I1? X cos x raised to power x. So this is 1. This is your 1. This is to be substituted at place of this much of thing. X1 cos x. Please see. This is to be substituted at place of derivative of this thing, because what we need to find is that dy by dx is what? Derivative of this thing plus derivative of this thing. Now let us find the derivative of second function. Second function. Okay. What is our I2 now? I2 is equal to x sin x raised to power 1 upon x. So taking log both the sides, log of I2 is equal to log of this thing. When you will take the log of this thing, log m raised to power n, so it will be 1 upon x into log of x sin x. X sin x. Okay. Now see, differentiating both sides. So when you will so this whole dash is equal to this whole dash. Okay. This is what? D upon d of x. So what? D upon dx. Okay, let me write it. I2 is equal to d by dx of this whole lot. 1 by x log of x sin x. X into sin of x. Okay. This is first function and this whole we will take it to be second function. Now this is what? D upon di1 I2 and log of I2 and di2 upon dx. Okay, and this is what? First function. First function is 1 upon x into derivative of second. Now derivative of second, please see, I am writing straight away. How? Log of this thing. So what it will be? It will be 1 upon first log, derivative of log x is, it is what? Log t. T is this whole log. So it is x sin x. And then derivative of this thing. This is the product of two functions. So first function into derivative of second, that is cos x plus sin x into 1. This is this thing. Now this thing can further be written to be what? Please see. Okay, it is okay, 1x you can multiply earlier. So better write it 1 upon x square sin x and then keep it like this only. X cos x plus sin x. That's all. this whole thing, and please see it d by it is 1 by I2, and so 1 by I2 and di, this is what you can write is I2 dash. This is the value which you have to get. So this I2 will get multiplied over here, and I2 is nothing but x, this whole lot, x sin x raised to power 1 by x. Please see, this is the answer. This is your equation 2. Put the respective values at place of 1 and 2. That will be the required answer. That will be the required answer. Now you have to practice it at your end. Otherwise, there is hardly anything difficult in it. Please, my request to all of you is that practice as much as you can. So we will take 1 or 2 more questions here. Then we will switch on to the parametric one. Okay. Now, so this is a fairly lengthy question which we did right now. Not a fairly big one. Once you practice it, then it will come too handy. Now question number 12, please look in. You have to find the derivative of, again here, x raised to power y plus y raised to power x is equal to 1. You have to find the derivative dy by dx here. So what you will do? Differentiate with respect to x. Please see, you have to differentiate with respect to x. So what you will get, d by dx of y raised to power x is equal to 0. Now, these derivatives, as you have been doing rightly now, let this be I1, this be I2. Derivative of this thing be I2. And then see, we will put the values here. And then see, we will try to find it out that what is the value of dy by dx now. Okay, so let us see how to find this thing, d by dx. So let I1 is equal to d by dx of x to the power y. Its derivative has to be found out. Derivative of this thing, x raised to power y. Okay, so what I will do, I will let I1 be this thing. So what I have to find is I1 dash basically. So so what I will do, I will find I1 dash. Okay, derivative of x raised to power y I have to find. So what I will do, I have no other option but to take log of both the sides. So log I1 is what? Y log x. See, log x raised to power y is what? Y log x. Differentiating both sides with respect to x. So d by dx of log of I1 is equal to what? D by dx of y log x. Okay. Now this is what? D upon di1 log of I1 into I1 dash. I1 dash is what? di1 upon dx. So this is what? Product of two functions. First function, derivative of second. Derivative of second is what? 1 by x plus log second function, log x into derivative of first, that is y dash. So this is what? So here I1 dash basically will be your this d upon d, log I1 is 1 upon I1. And this 1 upon I1 will get multiplied over here. Please see, 1 upon I1, I1 dash. This I1 I will multiply over here. Basically see what you will get is, this thing is equal to this whole lot. This I1 I will multiply over here. So I1 dash, finally, eventually what I will get is, I1 dash is nothing but I1. At place of I1, how much I'm going to write is x raised to power y. And this whole lot, please see, y upon x plus log x and y dash. Okay, this is equation 1. Now similarly, I have to obtain the equation 2, please see. And then see the derivatives I will be putting therein. Okay. So here the derivative of this thing. It was I1 dash is this thing I will put here. And then see this value is nothing but x raised to power y into y by x plus log x into y dash. Log x into y dash. In fact, we have to find y dash only. We will see how we can find it out. Now let I will now take the questions here. I will calculate I2, then I will substitute the value here in. So let I2 be equal to how much? Please see, it is y raised to power x. So take log both the sides. So log I2 is equal to log of x. So this is x log y. Okay. Now differentiating both sides with respect to x. So what I will get is d by dx of log of I2 is equal to d by dx of log of y. This is equal to what? D by dx of x log y. Please see, it is x log y. So first function into derivative of second. Derivative of second is what? Please see, d by dx of log of y plus log y into d by dx of x, that is 1. So this is what you will get. Now here again d by dx, here you will write, you have to differentiate this log I2 and then I2 dash. I2 dash is di2y upon dx. So this is equal to what? Please see, x. D by dx log y. So it will be d by dy, d upon dy of log y into dy by dx. Please see, this is important. Dy by dx plus log of y. And this is nothing. So d upon this is what? 1 upon I2 into I2 dash. Please see, is equal to x. And this is what? 1 upon y. 1 upon y into y dash plus log of y. And this is, therefore, I2 dash is equal to your I2, and I2 is how much? Y raised to power x into x upon y, y dash plus log of y. So this is to be, now, this is the value of derivative of I2. I2 is this thing and derivative of I2 is this thing. So now please see, we will put this value here again and then see, we will see how the rest of the things can be calculated. X raised to power y, see here this was the equation which was given to you, and what you have seen is that, now I will rewrite here, x raised to power y plus y raised to power x is equal to 1. You are differentiating this thing, d upon dx of x raised to power y plus d by dx of y raised to power x is equal to d by dx of 1. So now derivative of d by dx x raised to power y. X raised to power y, you have calculated this much of thing. So it is x raised to power y into y by x plus log x into y dash. Okay, plus. And then d by dx of y raised to power x. The value of d by dx of y raised to power x is this much. I2 dash PC was this thing. So it is, at place of this thing, what we can write is y raised to power x, please see, and x raised to power y and y dash, okay, plus log of y. Log of y is equal to 0. Is equal to 0. We will run this thing now. Please see. This is. Now here see, the terms containing y dash we will collect at one place, rest of the things we will transfer on the other side. Where are y dash coming? Here and here. So from these two, let us take y dash common. So when I take y dash common, so what I will get is here x raised to power y log x, and here what I will get is y raised to power x, x raised to power y, x raised to power okay, x upon y. Okay, so this is two terms containing y dash. Rest of the terms I will be keeping at one place. So plus x raised to power y into y by x, okay, plus y raised to power x log of y is equal to 0. So what will be the value of y dash now? Rest y dash is this much of thing. Please see. So this thing I will retain on one side, rest of the thing I will transfer on the other side. So it will be minus, this term whole will become minus. So it is x raised to power y and y by x, okay, y by x plus y raised to power x log of y upon this whole thing. So this is what, how much? X raised to power y into log of x plus y raised to power x by y, x by y. So this is the answer. You can leave it here, or if need be, you can further simplify it, do depending upon what answer you have to get it. So this is how, what you have to do it. Quite simple. There's hardly anything difficult here in. So this is how you will be doing it. Let us take a few other questions, and I think you have now gained good perfection till now, and we will take next question of your book. Please see the next question. Yes. What is the next question? Please see. It is again a simple one. Okay, I will take the question number 14. Cos x raised to power y. Cos x raised to power y. Cos x raised to power y is equal to cos y raised to power x. Cos y raised to power x. And you have to find the value of dy by dx. Simple. Take log both the sides. Taking log both the sides. So what value you will get is log m raised to power n is m log n. So m log cos x is equal to, when you are taking log m raised to power n, what you will get is x log cos of y. Now you have to differentiate with respect to what? X, both the sides. So differentiating it, d by dx of y log cos x is equal to d by dx of x log cos y. X log cos y. Now you have to be very careful. Now d by d, this is the product of two functions on the left side. This is first function, this is second function. Likewise here you can take this to be first, this to be the second. So both ways you are having product of two functions. So let us differentiate it by product rule. So first function y into derivative of second function d by dx of log cos x. Now I will write it log cos x, derivative of this thing. First I will take the derivative of log. So it will be 1 upon cos x, and then derivative of cos x, it will be minus sin x. Minus sin x. First function into derivative of second. This is the derivative of log cos x. Plus then log cos x, second function, into derivative of first. So it is y dash is equal to, likewise you have to do it here. It is a product of two functions. First function is what? X. And derivative of second function. Now please see, derivative of second function here you have to be careful. It is, you are differentiating with, see, with respect to x. So cos y you will put t. So log t will be fetch you what? 1 upon cos y. And then derivative of cos y is to be taken with respect to x. Please remember. So it will be cos y, derivative of cos y. Y, it is again a function of function, please see. Likewise here it was straight away. Please see, try to understand the difference. Here it is cos x. You were differentiating log cos x. So 1 upon cos x. Cos x was the internal and then cos x was to be differentiated with respect to independent variable x. That's why you got sin x over here. But here the situation is different. Here first log cos y is to be kept as internal function, and you will differentiate log of t with respect to t. T is cos y. So you are getting 1 upon t, and t is cos y. Then cos y again is a function of function. Please remember, because this has to be differentiated with respect to independent variable x. So here see what you will do. Here see, please see d by dx of cos y. It is not only minus sin y. Here see y has to be kept to say is equal to p. So it is d upon dp cos of p into dp by dx. Please see, dp by dx is nothing but dy by dx. It is dp by dx. So it is minus sin p. P is your y. P is your y, and then dy by dx. So this thing you have to keep it. At times students, so please see log cos y is what? 1 upon cos y into minus sin y and y dash. Here see this y dash was not coming. Here y dash was coming because it was the derivative of this thing. But in the differentiation of log cos x, nowhere see this derivative y dash term was coming. So with this understanding now what it is? Y minus y tan x plus log cos x into y dash is equal to what? Minus this thing plus, and then what? Where we have written. See here we missed out one term. X into derivative of this thing plus one more thing. See here plus you will write log cos y and then derivative of this thing, that is 1. So it will be here x sin y minus tan y minus x tan y into y dash plus log cos y plus log cos y. Plus log cos y. terms containing y dash you collect at one place. This is one term, this is another term. So bring this time and make this other side. So y dash is what? Log cos x from here, and this will become plus while coming this thing. So it will be x tan y, and it is y tan x when this thing. So y tan x plus log cos y, and so y dash will be y tan x plus log cos y upon this whole lot, log cos x plus tan y, tan y. So it won't cancel? Yes, it won't cancel. So this is the answer. So this will be the answer. This is how you would be doing it. Now let us take the next exercise here. I think there is hardly anything difficult in it. Okay, just check in the last question. Again a simple one. Direct answer. Yes, 18th question PC. If u, v and w are the functions of x, then show that d by dx of, yes, u into v into w is equal to this whole lot. So quite simple, nothing difficult in it. Take this to be second function, this to be the first function. So it will be what? First function, u into derivative of second, d by dx of v into w, plus second function, v into w into derivative of second, du by dx. Now u into this thing, again what you will write? First function into derivative of second plus second function into derivative of first, dv by dx, plus v into w du by dx. So this is your u into v dw by dx plus u into w dv by dx plus dw du by dx. So simple it is, nothing difficult. So this finishes your this exercise. Now let us take the questions of the parametric functions here. Again, now I am doing at 5.6 exercise here. Parametric formula we have already told you. Okay, we will take, see, first 4-5 questions are too simple. I will take the fifth one, okay, or sixth one I am taking, question number 5 I am taking, because first 4 are too easy. X is equal to how much? Cos theta. Cos theta minus cos 2 theta, and y is equal to sin theta minus sin 2 theta. You have to find dy by dx. So in parametric form, what you have to do is you will find dx by d theta, quite simple. Dx by d theta is what? D by d theta of cos theta. Cos theta is what? Minus sin theta. And minus cos 2 theta is what? Minus sin 2 theta into 2. Into 2. Okay, and that minus will make it plus. Please see, minus will make it plus. Cos 2 theta, derivative of cos is minus sin 2 theta. That minus will make it plus. Minus sin 2 theta and then 2 theta. So it will be 2. And likewise here, dy by d theta will be what? It will be cos theta minus sin 2 theta is what? Cos 2 theta into derivative of this thing, so 2. So dy by dx, you know, it is nothing but dx, dy by d theta upon dx by d theta, and this is dy by d theta value is here, minus sin theta plus 2 sin 2 theta. Okay, so you can simplify it or you can write like this only. See what you will do. If you write 2 sin theta cos theta, then sin theta can be taken to be common. So what you will get, minus 1 plus 2, 4, and sin cos theta here you will write, and this thing will be what here, this thing you can further simplify, cos theta and then minus what, 2 cos 2 theta. 2 cos 2 theta you can write to be what 2 cos square theta minus 1. So this is cos theta minus 4 cos square theta plus 2. Plus 2. Or see, you need not write it, you can simply put it is like it is cos theta minus this much of thing. I don't know what the answer is, but that simplification you can do it. So this will be the answer. You can leave it up in here, no issues. Now I will take another good problem here. No good problem, only see you have to practice it. Method is okay. Question number 7. Question 7 and B seems to be x is equal to sine cube t upon how much? Under root cos 2t. Under root cos 2t. Okay, and what is y? Y is your cos cube t upon, please see it is cos cube upon under root cos 2t. Cos 2t. Okay, see, let me do it. Dx by dt. Dx by dt. This quotient rule here. So what is the formula? Quotient is square, so it will be cos of 2t. That quotient, that is under root cos 2t, into derivative of sine cube t. Please see, derivative of sine cube t, how it will come? Sine cube t can well be written to be this much. Y is equal to this is sine cube t. So it is x. What is this innermost function? X cube. And then what is the inner function? Sine t. And what is the outermost? X cube. So here sine t you have to put to be p. So its derivative, if you have to write it, so dy by dx. Now please see how. You will put sine t is equal to p cube, and p cube has to be differentiated with respect to p. So that will fetch me 3p square. So 3 and p is what? Sine t. Sine t is square. And then the derivative of sine t. Sine t is what? Cos t. Cos t. So this is the dy by dx here. So it is minus sine here. Okay. Cos 2t into derivative of this thing. So this is 3 and sine square t and cos of t minus, this is cos please, minus derivative of this thing, this is numerator, derivative of denominator. Denominator is what? Under root cos 2t. So under root, first you, so that will give me what? Please see, under root of cos 2t. Under root cos of 2t, its derivative. First you will put cos 2t is equal to p. T is equal to how much? Cos 2t. So it is under root p. So it is d upon dx of this thing. So it will be what? D upon dp into dp by dx. So it is 1 upon 2 root p and dp by dx from here. It is what? dp by dx from here will be what? Cos 2t minus sine 2t into 2. Into 2, please see, it is again a function of function. So it is 1 upon 2 root p, 2 root p is cos 2t. So 1 upon 2 under root cos 2t and what else? Yes, into minus sine 2t, this minus will make it sine 2t and what else? 2 into 2. Okay, so this 2 will cancel with this 2. So let us take this thing. So here this root cos 2t will fetch you what? Cos 2t into sine square t cos t plus sine cube t and sine 2t and what else? Nothing upon cos 2t into under root cos 2t. Please see. This is the derivative here. This is one part. This is dx by dt. Dx by dt. Now, so I will write this thing somewhere separately so that, or I can take something common here. Okay, sine square t, 2 sine t, cos t. Okay, I will bracket 2 sine t cos t. So what, and then I will take, how much take? I can take common sine square t and cos t I will take common. So this will give me what? 3 cos 2t. Here 3 cos 2t I will left, and here sin cube t and 2 sin t cos t. So 2 sin square, 1 sin, so plus 2 sin square t and cos t comes common upon this much of thing. Cos 2t root cos 2t. This is your dx by dt. Dx by dt. I will keep this thing here at one place and I will rub the rest of the things so that now I will find dy by dt. Dy by dt again, see, same thing from here. Dy by dt, it is quotient square, that is cos 2t, under root square is cos 2t, under root cos 2t, and the derivative of this thing. So that will be 3 cos square t, and cos t is minus sin t, that's all. Minus numerator cos cube t, please see, cos cube t, and derivative of this thing. A derivative of under root cos 2t will be what? 1 upon root, this root x is what? 1 upon 2 root x, and cos 2t, and then cos 2t will give me what? Minus sin 2t, this minus will make it plus sin 2t, and into 2, this 2 cancels. So again, see, you can simplify it. This cos root t will give me what? This is your dy by dx now. This is 3 cos 2t. Please see this LCM I am taking, and it is cos 2t, cos of square t minus sin t, okay, and plus see, this 2 sin 2t I will write it 2, and sin t and cos t is cos 4t upon cos 2t into root of cos 2t. This is this much. Let me see if something comes common out of it. Here, cos square t, sin t, cos 2t. Okay. So cos square t and sin t I can take common here. Cos square t, sin t I can take common here. So it is minus 3. Please see, cos 2t, cos of 2t plus 2, and what else? Cos square t. Whole upon cos 2t under root cos 2t. So this is my dy by dx. Now dy by dt, and this is my dx by dt. So dy by dt will be, see, this here, these two terms will cancel when I will divide it, and so what I will get as answer is dy by dx is equal to dy by dt. So this is, please see, it is dy by dt only. So it is cos square t, sin t coming common over here, and then minus 3 cos 2t plus 2 cos square t, 2 cos square t. Please see, rest of the things I will rub it. And what else? Upon dx by dt. And dx by dt is your this whole lot. This has terms cancelled, so what you will get is cos sin square t, cos t, and within bracket 3 cos 2t, 3 cos 2t plus 2 sin square t, 2 sin square t. So see, you can leave it up here also if you feel like cos power cancels and 1 sin t cancels. So cos t upon this thing is cot t, and then this whole lot. Now please see, I have checked in your answer, and interestingly it is given, answer is minus cot 3t. Minus cot 3t. Now you will be thinking that it is something wrong, but no. If you simplify it further, I think you can get the answer very easily. How? Because you want things to be written in terms of cot 3t. Now what is this cot 3t? Now calculating this cot 3t will be a cumbersome process for you people. So now see, you should be good enough. Let us calculate tangent 3t. 2 t plus t. So tangent 3t is what? Tangent 2t plus tangent t upon 1 minus tangent 2t into tangent t. And this tangent 2t you can replace it by 2 tan t upon 1 minus tan square t plus tangent t. At tan t you have to be quick enough. Tangent 2t, if you don't know the formula, 2 tan t upon 1 minus tan square t into tangent t. Now take this common, so what you will get? 2 tan t plus tangent t minus tan cube t upon, yes, 1 minus tan square t, and then 1 minus tan square t minus 2 tan square t, so it will be minus 3 tan square t, and so it will be your 2 tan t 3 tan t minus tan cube t upon 1 minus 3 tan square t. Okay, see, this is your tangent 3d. So cot 3d will be reverse of this thing. So it will be what? 3 tan square t upon 3 tan t minus tan cube 3. This is your cot 3t. Cot 3t. Let us see if we are getting the same thing over here. That please see, we will see, because now everything has to be kept in terms of t. So okay, in terms of tan, if this answer is to be obtained, so what we will do is minus 3 cos 2t, let us write to be what? 2 cos square t minus 1 plus 2 cos square t, okay, let it be, upon 3 cos 2t, 3 cos 2t. We want answer in terms of, okay, no, let us then write in terms of sign here. Because 3 cos 2t, let me write 1 minus 2 sin square t, and this 2 cos square t, I will prefer writing 1 minus sin square t, because I want this thing, okay, and then the 3 cos 2t, here I will write 2 cos square t, 2 cos square t minus 1 plus 2 sin square t, I will prefer writing 1 minus cos square t. And this cot t I will write 1 upon tangent t, PC. Minus, so what it is giving me? Minus 3 plus 6 sin square t, okay, sin square t plus 2 minus 2 sin square t, okay, upon, this is giving me 6 cos square t minus 3 plus 2 minus minus 2 cos square t. Yes, so it is 1 upon tangent t minus 3 plus 2 is minus 1 plus 6 sin square t minus 2 sin square t plus 4 sin square t, okay, and what else? 6 cos square t minus 2 cos square t is 4 cos square t minus 2. Now see, what we can do is, because we have to answer this thing, minus 1 we can write to be what? Minus, okay, it is to be written as sin square t plus cos square t plus 4 sin square t, and upon 4 cos square t, please see, 4 cos square t, and what is this? Minus 1 again we will write to be what? Sin square t plus cos square t, and then see, this whole thing we will divide by cos square t. So what we will get is 1 upon tangent t, okay, and then it is cos square t will give me what? Minus tan square t plus 1 minus plus 4 tan square t, tan square t here, and upon here 4 cos square t, it will give me 4 minus sin square will give me what? Cos tan square t and plus 1 1. So please see what it is giving me ultimately is minus, I will take off on this thing, tan square t plus 4 tan square t, it is minus here, please see, it is minus over here, so minus tan plus 3 is 3 tan square t, please see, it is no minus here, it is minus tan square t plus 4 to 3 tan square t minus 1, and it is here 4 minus 1, that is 3, and minus tan square t, okay. So it is this much of thing, please see, and 1 upon tangent t, so please see you are getting the answer, 1 minus 3 tan square t, if you take minus sign common, so 1 minus 3 tan square t, and then this 1 upon tangent t, 3 tan t minus tan cube t, 3 tan t cot t, so it is minus cot of t. This is how you have to do it. So this is how these questions have to be attempted. I will take one more question here and then see, I will finish this exercise, and then we will proceed with the Other questions, few questions. Now we are inching towards our last article, that is second derivative and onwards. I will take one or more question here because the last one I am taking, the questions here are too simple. X is equal to under root, please see, a sine inverse t, a raised to power sine inverse t, and y is equal to how much? Y is equal to under root a cos inverse t, a cos inverse t. Show that dy by dx is equal to, show that dy by dx is equal to how much? Minus y by x. Okay. So again see what is, it is given in the parametric form. So dx by dt, let us determine from here, dx by dt. So d by dt of what? Under root a raised to power sine inverse t. Okay. What is the derivative of this thing? First see, it is the outermost function in what? Is square root x. So this a sine inverse t is to be kept as t, and p, and you have to differentiate this under root x with respect to p. So it will give you what? I will write it. Root of x, you know, it's the derivative. Root of p is under 1 upon 2 root p. P is a raised to power sine inverse x into dp by dx. A raised to power sine inverse t. Okay. Derivative of what? D by dx of a raised to power sine inverse t at the first step. So now this is what? 1 upon 2 under root a raised to power sine inverse x into d by dx of this thing. So what it is? Sine inverse t you will put equal to q. So a raised to power q, d by dx of a raised to power q. So it will be d by dq of a raised to power q. A raised to power q is what? A raised to power q into log of a. Log of a into dq by dx. dq by dx, and then what is q? Q is your sine inverse t. So this is basically your 1 upon 2 under root a sine inverse t into a की power q. What is q? Q you have done as sine inverse t. Sine inverse t into log of a into this thing into log of a, and dq by dx is sine inverse t, and sine inverse t is nothing but 1 upon under root 1 minus t square. 1 minus t square. So this is what dx by dt is. So I will write it somewhere. Here I will write dx by dt is what? This much of thing. Dx by dt has been formed to be what? 1 upon 2 under root a raised to power sine inverse t into a sine inverse t sine inverse t into log a, log of a, and then 1 upon under root 1 minus t square. Let us similarly calculate this. Y is equal to cos inverse at. Okay. Yes. Y is equal to cos inverse this thing I am doing over here. So dy by dt here is what? D by dt of under root p. And what is p? P is your a cos inverse t. A raised to power cos inverse t is a raised to power cos inverse t. Please see, it is not a into this thing, it is a cos inverse t. Okay. So d by dt is what? It is d by dp of root p into dp by dx, and this is what? 1 upon 2 root p. P is what? A raised to power cos inverse t, and dp by dx. dp by dx, let us calculate from here. So what we will do? We will put q is equal to how much? Cos inverse t. So it is p is equal to a raised to power q. So d power q, which is nothing but d upon d की power q, a की power q into dq by dx. And dq by dx will be calculated from here. It will be minus 1 upon under root of t square. Okay. And d raised to power dq of aq is what? A की power q into log of a into dq by dx is minus 1 upon under root 1 minus t square. So put this value over here. So it is a place of this dp by dx. So dp by dx is this much of thing. So it is a raised to power minus. So minus sign here. Minus a raised to power cos inverse t, okay, and then log of a and what else? 1 upon under root 1 minus t square. Rest of the things I am writing here. This is what I got as, yes, this is my dx by dt. This is dy by dt, okay, dy by dt, and this is my dx by dt dividing both the sides. Here, what I will get is, now please see, whatever your x is, now answer has to be obtained to be y by x. So x a under root a raised to power sin t, what it is? X. So I will write it to be this way. It is x upon this 2 under root of x log a here and 1 upon under root 1 minus t square. Likewise, this thing is what? Minus 1 upon 2, and this is y. So 2 under root y under y and log a, and then it is 1 upon under root 1 minus t square. This is now 3, this is your equation 1. So now dividing this by this, so what we will get is dy by dx is equal to how much? Please see. What we will cancel? Here see, this under root t square will cancel here with this thing, log a will cancel with log a, and then 2 will cancel with 2, and what you will get is, see this effectively you will get here as minus y upon under root y, and this is what? Dx by dt is what? This is x. So x upon under root x. So this is what? Minus you are getting as under root a sin inverse t. Dy by dx, you have to get to be y by x. Somewhere something went wrong into x upon dt by dt, and then somewhere we have added, but so what we are getting is this thing x is under root and this is minus root y by root x. Answer should be y by x. Answer is y by x. So we have done some error. Please check it. Please check it. We will stop here. Some mistake we have committed somewhere. This x is coming. Let me check it. A sin inverse t. X. Oh yes. Please see. It was given that x. You have kept x is equal to under root of this thing. Please see. Sin inverse t. So root a sin this thing will be x square. So here it will be. Please see y square, and here it won't be y under root of this thing, and this is no. Yeah, just check it. Just check it. A slight mistake you will be able to identify as I will do it. So with this, thank you. Now see, we have finished up to exercise 5.6. 5.7 you can do. It is second order derivative. Okay, we will take it next day. And Mean-Value theorem and this Lagrange theorem, that is what is left in this chapter. We will finish it. Okay, thank you students. Next time we will meet. Okay, thank you.